Hello and welcome back to CBSE Tech Talks. Today in this video we are going to understand conversion of different number systems with fractional part. It is an extension of previous video. Let's start with. Before starting, let's understand what will be the learning outcome of this video. After watching this video, learners will be able to perform number system conversions including decimal, binary, octal and hexadecimal. They will be able to convert numbers with fractional part between various number systems. They will be able to apply grouped conversion between binary, octal and hexadecimal number system. Before proceeding further, let's again introduce about number systems. Computer uses binary to represent data internally. That's why binary number system is required to understand. Decimal number system is used in our daily life. We have been using, so we can correlate the other number systems using decimal number system. That is also important. Octal number having base 8 and hexadecimal numbers having base 16 are used for memory and compact representation in the system. Now when we talk about the number system, they are base of all the number systems or radix of the number system. When we talk about binary number system have radix as 2 and it uses digits 0 and 1. Octal number system have base 8 and uses digits 0 to 7. Decimal number system have base 10 and it uses digits from 0 to 9. Hexadecimal number system have base 16. It uses digits 0 to 9 and then A to F. So A is used to represent 10, B is used to represent 11, C is used to represent 12, D is used to represent 13, E is used to represent 14 and F is used to represent 15. Now first of all, how to convert decimal into binary. Now as I told you, in this we will be using the fractional conversion also. Fractional part will be taught how to convert fractional part into other number. So integer part, in the case of integer part, we divide the decimal number by 2 and record remainders top up. It means from the bottom we will be moving up, while the fractional part we multiply by 2 and record integer part repeatedly. Now let's take an example here. I will be showing you using an example. Conversion of decimal to binary. Let's take an example 25.625. This is in decimal, so we write here base and equals to, we will be writing here what will be the binary equivalent of that. First of all, convert 25. Okay. And then we will be converting the other one. So how to convert 25? We have to divide by 2. So divide by 2. When you will going to divide 25 by 2, you will be getting quotient as 12 and remainder as 1. Again divide by 2. You will get quotient 6, remainder 0. Again divide by 2. Quotient will be 3, remainder will be 0. Again keep dividing till the quotient is not 0. Again divide by 2. When you will divide 1 by 2, you will be getting quotient as 0 and remainder will be 1. So then we have to go from bottom to up. So 25 will be 1, 1, 2 zeros and 1. This is 25. Decimal is converted into 11001. Now take the integer part is done. Now take the fractional part. take fractional part and multiply by 2. When you are going to multiply this number by 2, you will be getting 1.250. So this integer part which you have just now got, this has to be written as here. Now take this 0.25. 0.25 into 2, you will be getting 0.50. Take this in 0, so 0 will come here. Now again multiply 0.5 by 2, you will be going to get 1.00. Now as the digits after decimal point are zeros, we will be stopping here. So all together if we write here, so it will be 11001 point. Now these numbers will be from top to bottom. So 101. I am repeating, the integer portion is to be divided by 2 until you reach 0 as a quotient, and the integer part or the fractional part need to be multiplied by 2, and you have to keep taking the fractional part. Integer part you have to, you can say, record, and in decimal part you have to keep multiplying by 2 until all the digits after decimal point are not 0. I hope this is clear. Let's move to the next conversion. Now the next one is decimal to octal. As the name indicates, you have to divide by 8. So integer part needs to be divided by 8 and collect remainders top up. And fractional part multiply by 8 and collect integer part. The way we have done for the decimal to binary, the same way we will be going from decimal to octal. Let's take an example. I am taking the example as 58.375. This is in decimal and you have to convert into octal. So in the previous video also I explained you how to convert decimal into octal. You have to divide by 8. 8 sevens are 56 and 2 remainder. Again divide by 8. Now quotient will be 0 and remainder will be 7. Okay. So if we write separately 58, which is decimal, and the equivalent of this decimal is 72 in octal. So we will go with this way. Now take the fractional part and multiply by 8. And the way we multiply in the previous example, decimal to binary by 2, we have to multiply here by 8. 8 5s are 40, carry 4. 8 7s are 56 plus 4 is 60, so 0, carry 6. 8 3s are 24 plus 6 is 30. Now it is having 3 digits after decimal point, so this way. Now this time we have reached to all the zeros, so we will stop here only. So you can say the complete conversion is 72.3. So 58.375, which is in decimal, is equivalent to 72.3 in octal. I hope it is clear. Let's move to the next conversion. Decimal to hexadecimal conversion. As the name indicates, we are going to divide by 16. So integer part needs to be divided by 16 and collect remainders top up, and fractional part need to be multiplied by 16 and collect integer parts. Let's take an example. Here we will be taking example as 254.625. You may take any. I am taking these examples. You can try for few more, and we have to convert into 16. So let's take the integer part, divide by 16. So 16 ones are, so you will get here remainder as 9 4. So 16 5s are 80 and remainder is 14. So 14 can't be written here, so we will be writing here E, because we know that A is 10, B is for 11, C is for 12, D is for 13, E is for 14 and F is for 15. So we will be writing here E. Again divide by 16. When you will divide this by 16, you will be getting remainder here 0. Sorry, quotient as 0 and remainder will be 15. So 15 is to be written as F. Okay, so we can say 254, which is in decimal, equals to FE in hexadecimal. Let's take the fractional portion. 6 to 5 multiply by 16. 16 5s are 80, so carry 8. 16 to the 32 plus 8 is 40, carry 4. 16 6 are 96 plus 4 is 100. Decimal point will come here. So this is only the, you can say, integer part, rest all is 0. And how to represent 10? 10 is represented by A. So we can say it will be equivalent to FE point A. So 254.625, which is in decimal, is equivalent to FE point A in hexadecimal. I hope it is clear. Let's move to the next conversion. Binary to octal. When we are converting binary to octal, we will be grouping in the group of 3 from right for integer and from left for fractional. Let's take an example. If I have number 1, 0, 1, 1, 1. Okay, point 1, 0, 1, 1, 0. So for the integer part, we start from the right side. It means we will start from this right side and we will go to left. And fractional part we will start from left side and we will go towards right side. Make a pair of 3. So this is a, you can say, group of 3. Make other group. Now this group consists of 2 only. We have to make 3, so we'll be putting one more 0. So this is the other group. Same ways, this is one group and these are left with 2 only, so make it one more. So this is the other group. Now how to convert? We know that when we go with the conversion, we have to go with 4 to 1. Now I will tell you what exactly is 4 to 1, though I have explained in the previous video also. These are the positional values for binary number. Now how come? This is 2 to the power 0, this is 2 to the power 1, and this is 2 to the power 2. Now to make you more clear or to make you more understand, we know that the decimal number system, we have ones, tens, 100, then we have 1000. How we go with? It means 10 to the power 0, this is 10 to the power 1, this is 10 to the power 2, this is 10 to the power 3. It means these are the base and these we go with the, after you can say before decimal point we start bar as 0, 1, 2, 3 this way. So we will be going to go with positional values 4 to 1. Now when we have made the group of 3 digits or 3 bits, now wherever we have 1 on the positional value where the number is 1, we will add the positional value for those. So in this case we have 1, 1 and 1. It means for 4, 2 and 1, for all the digits we have 1, or for all the bits we have 1. So 4 plus 2 is 6, 6 plus 1 is 7. So this is, you can say in hexadecimal, 7. 0, 1, 0. So 4 is 0, 1 is 1 and again 1 is 0. So it is 2. So this is 2 point. Now again go with 1, 0, 1. It means 4 is 1, 2 is 0 and 1 is 1. So 4 plus 1 is 5. And this is 1, 0, 0. So it is 4 is 1, rest all are 0. So it is 4. Now this is the octal equivalent of this binary number. Am I clear? From the, on the left side of, you can say, integer part has to be started from right side to make, we have to go with the groups of 3, while the fractional portion is to be started from the left side. So left, this way we will keep on going on and we will make the group of 3. If number of bits are less, either this side or that side, if the number of bits are less towards the, before the decimal point, we will put zeros on the left side, while after decimal point, if digits are less, we will be putting 0 on the right side. I hope it's clear. Let's move to the next conversion. Binary to hexadecimal. Now in this case we will be making the group of 4. Why 4? Because to represent 15 digits, 0 to 15, that is altogether 16, we need 4 bits to represent. So let's take an example. We will be going with the numbers 1, 0, 1, 1, 0, 1, 0, 1. Point 1 0 1 0 1 0. Now we have to make this side 4 and the other one is this side 4. Here this is 4 and this is only 2, so we will putting 2 more zeros. And what do you mean by 4 bits here? 4 8 4 2 1. We will be going the same way we have gone through for the octal numbers. We will be adding the positional value of the digits where we have 1. So in this case we have 1 at the positional value of 4 and we have 1 at the positional value of 1. So 4 plus 1 is 5. In this case we have 1 at the positional value of 1, we have 1 at the positional value of 2 and we have 1 at the positional value of 8 also. 8 plus 2 is 10, 10 plus 1 is 11. And how to represent 11? By B. I told you in the previous. I am writing again here. 10, B is used to represent 11, C is used to represent 12, D is used to represent 13, E is used to represent 14 and F is used to represent 15. So this is what the conversion point. Now again at the place value of 8, positional value of 8 we have 1 and at the positional value of 2 we have at 1. So 8 plus 2 is 10. So 10 is represented using A. Now in this case we have only at the place of 8. So this is hexadecimal equivalent of this binary number. I hope it's clear. Let's move to the next one. Octal to binary. We will take the digits and we will represent using a 3-bit binary. Now octal number will have digits from 0 to 7 only. It can't go beyond 7. So let's take an example. If I write here 76.52, let's take an example, which is an octal number and to be converted into binary. Okay. Now we will go with 4 to 1 place value, the positional value only. How to represent 7? 4 plus 2 plus 1 is 7. So all will be 1. How to represent 6? 4 plus 2. So only for 4 and 2, positional value of 4 and 2 we will have 1. For the positional value of 1 we will have 0. So 1, 1 and 0. Point. How to represent 5? 4 and 1. So we will have 1, 0, 1. And how to represent 2? Only for this. So 0, 1, 0. Should we take one more? Let's take one more. 23.76 equals to. How to represent 2? 0, 1, 0. So 0, 1, 0. How to represent 3? 2 and 1. So 4, 1. Okay. How to represent 7? 4, 2, 1. So 4, 2, 1. And how to represent 6? 4 and 2. I hope this is clear. Let's move to the next one. Hexadecimal to binary. So in this case, we will be representing using 4 digits or 4 bits of binary. Let's take an example. You can say B9.AF. A10, B11, C12. After few conversions you will be able to recall, but initially you need to note down somewhere so that there will be less chances of errors. Now B, and how to go with 8, 4, 2, 1. How to represent B? 11. How to represent 11? 8 plus 3. It means at the place value of 8, at the place value of 2 and at the place value of 1 we will be having 1. For rest all cases we will have 0. So we will have 0 only for the place value of 4. So 1, 0, 1, 1. How to represent 9? 8 and 1. So for these two we will have zeros while 8 and 1 will be having 1. So 1, 0, 0, 1. What is A? A is 10. So 8 plus 2 is 10. So 8, at the positional value of 8 we will have 1. At the positional value of 2 we will have 1. And at the positional value of 4 and 1 we will be having 0. So 8 and 2. F is 15. So 8 plus 4 is 12. 12 plus 2 is 14. Plus 1 is 15. So all 4s will be 1. Is it clear? So we go this way. Let's move to the next slide. Now these are few tips which you can remember to summarize. Decimal number, if you are converting to binary, we have to divide by 2. Integer part and fractional part we have to multiply by 2. So same way if you are converting the octal, so divide by 8 and multiply by 8. If hexadecimal, then divide by 16 and multiply by 16 if you are converting decimal number into any other number system. Now when we talk about binary to octal, we have to group 3 bits and then we have to write the octal equivalent to that. If you are converting binary to hexadecimal, we have to group 4 bits and then you have to write the equivalent of those 4 bits. Especially when we are converting octal and hexadecimal to binary, replace each digit directly. You can straight away write the digits as I showed you. With this video is over. I hope all the conversions are clear to you. If it is not clear, you may write in the comment, or if you want some other to be done in the video, I will be happy to share that with also. Now for the number system, we will be having third video also, which will be taking the character sets. So don't forget to watch the next video, and to watch and to get the video the moment it is uploaded, you should share, subscribe and like the video so that I can keep making videos for you. Okay then, see you in the next video.